that are designed specifically to light up or glow when there's a decay of the carbon-14 atom. Now we got to make sure we wash our container completely out so that so the entire sample gets into our vial. Let it drain for a few seconds. Let it drain a little bit there, and get all the carbosorb drained out. Just wipe off the top so we don't get any this caustic material into our scintillation counter. There we have it. Right now, let's shake it up. Let's see. If we would put this in a ultraviolet, in fact, maybe I can do that. Let's see. You can see how that fluoresces with the ultraviolet light. Okay, let's put this in the, this is the liquid scintillation counter, and this apparatus has an elevator in the back that pulls the sample down between two opposing tubes that looks at this vial. There'll be one tube on one end, one on the other, and it's encased in lead so that to minimize the background radiation. And when both of these tubes see a flash simultaneously, then that's the count. If only one tube sees it, then that could be static from other electronics in the machine, or it could be from cosmic radiation that is not relevant to what we're looking for. So we'll put this in the cassette. This cassette automatically travels around, and then when the time comes, it'll go down into the elevator and go between the two tubes. Okay, we have all of our data collected, and we draw it out of the liquid scintillation counter in this format, but this isn't good enough to do the calculations for us. So we combine all the data that we've found out. We need the sample weight, we need the number of counts per minute that the sample has, and we need to know the background rates, and we put all this together on the computer in this spreadsheet. And for example, some of the assumptions we have to make are, and the first assumption we make is that the activity of the radiocarbon when this coal was formed is the same as what it is now, and that's a very broad assumption, because right now we measure in our machine that the activity of the carbon-14 in the plants is 13.39 disintegrations per minute. So that's if a plant had just died today. And if we make the assumption that the plant that died 10,000 years ago, which is what we got on this particular piece of coal, that it also had the same disintegrations per minute when it was living. Now we don't know what it was then. As we mentioned earlier in the program, that we have to calibrate this value based on things that we know have lived at that time, and it's pretty hard to find things that lived that long. Tree rings are part of the equation, but there are problems with tree ring dating also. But let's assume that this value is really only about half of what it is now. And I'm going to change this on the computer to show you. Watch the date. This is the RC date, the radiocarbon date, 10,412 years. If I change this to just half, let's say 15, you see it drops immediately down to 4,575 years. So there's a very strong influence of this initial value that is very difficult for us to obtain in order to determine what the true age of this material is. Now, if we return that back to what we consider the value today, we're back to 10,000 years. Let's say that the carbon dioxide in the atmosphere when it was living had a higher concentration. And one of the reasons we believe that this is a possibility is because when the dinosaurs lived, they lived in an environment that had very lush vegetation. Now we know if you increase the carbon dioxide concentration in our atmosphere, that plants will grow exponentially at a greater rate. So let's just increase that by 2 and say maybe back when the dinosaurs lived. And you can see here again, by doubling the concentration, you see that the radiocarbon date dropped down to 4,600 years. Let's return that back to today's date. But if the atmospheric pressure at that time was different, let's say 1.5 times what it is today, and there's reason to believe that that's a possibility because pterodactyls, for example, remember those large birds that are reptilian type? They had huge wings, and in order for those animals to fly, aeronautical engineers have demonstrated that the atmospheric pressure today is insufficient to allow them to leave the ground. If we would increase it, say 1.5 times, you can see that making it a more optimistic environment for pterodactyls to fly, then the radiocarbon age would also drop to 7,000 years. So what is the real carbon date? Well, we have to make many assumptions, and that's one of the advantages of our lab. We're willing to step outside of the box, so to speak, on what the conditions were like in history. And if we look at it from if we take the biblical record and say that the Earth perhaps had 1.5 times the concentration of carbon dioxide before the flood, which allowed the dinosaurs to live and provided lush vegetation from pole to pole practically. And we also, let's say we increase the atmospheric pressure by 1.2 times. Then you can see we're down to a date now for this sample that was 10,000 years, down to 5,553 years. So we think we can make some reasonable assumptions to support our belief that the age of the Earth is really considerably younger than the uniformitarian scientists would say. And again, if we restore everything back to the way it was when the uniformitarian makes his estimate, it's 10,000 years. But we don't believe that's true. We think that we have considerable reason to believe that it could be considerably shorter than that. Well, if you remember, we started out with a lump of coal from central Ohio, and we raised several questions about how old it is. And remember, in the beginning, we said that an evolutionist would say that this is 300 million years old. Now, that's very, very old. However, you see that we have detected radiocarbon in our laboratory studies that indicate that it's well under 50,000 years of age. How is that so? We think we have directly dated this material using laboratory technique where the evolutionists has just implied that it's that old based on the material that it's associated with, and that material also has many multiple assumptions